Section 21.2, angle side congruence theorem. So if two angles and a non-included side of one triangle are congruent, to the corresponding angles, and a non-included side of another triangle, then the triangles are congruent. And here's what that looks like. We've got an angle and an angle, that's congruent. Another angle and another angle, that's congruent. And this right here is our non-included side. By included, the included sides of these two angles would be, right, this would be an included side, that would be included side. No, just the one, right? These two angles share this side. So as you can see, the side we're talking about that's congruent is not included, right? It's definitely not this one. So hopefully that makes sense. Two angles and a non-included side. So let's take a look at this example. We've got angle A, and that appears to be congruent to angle D. And then you've got angle B, and that appears to be congruent to angle E. And then you have, let's see, angle, the non-included side, right? The included side would be this side between the two angles. The non-included sides are here, 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 and here. So these are definitely the same, right? So we're talking about AC is congruent to DF. And both these sides are non-included sides, right? This is included. And those are non-included. Right, and that's, one of the conditions. So we have basically an angle, side. So these two triangles are definitely congruent. Triangle ABC is congruent to triangle DEF. Give you a moment to get caught up. In this next section, we got to find out if we've got an angle, and a non-included side. Well, you definitely have angle C and angle E. Right? Angle C is congruent to angle E, and there's one of our angles, an angle condition. And we also have angle B is congruent to angle F. And the reason I can tell, right, are these hash marks. That's what these hash marks mean. And then angles, they look like curve marks. But now let's take a look at the side. The side we're talking about is CB and EF. There's our angle and our angle. And it does appear that these are congruent, right? They are congruent. But if you can tell by the tone of my voice, there's something that's not right about these two sides. And the thing that's not right is these are included sides, right? Included. And you basically know the wrong side is congruent. You need to know that the non-included sides are congruent. And the non-included sides I'm going to draw right now in purple. If either of these purple sides were congruent, then we could tell if the two triangles are congruent, at least by the angle side theorem. So I have to rule that because this is an included side and the formula requires, I shouldn't say formula, the theorem, right? The theorem requires the congruent side to be non-included, as in not between the two angles, right? Not between the angles. That these two triangles, at least by the angle side theorem, not congruent. So I hope that makes sense. It's because basically those sides in red, CB and EF, are between the two angles. And your theorem requires that they not be between the two angles or be non-included. So that's why these two triangles aren't congruent. The theorem conditions are not met, right? The side is not met. So let's take a look at this next example. Well, we've got an angle and an angle. Angle C is congruent to angle E. Condition 1 met. Angle B is congruent to angle D. Condition 2 met. Now that right there is an included side. Included. Making everything else not included, right? These are not included sides. I'm going to say NI for short, not included. So the question is there a condition where corresponding not included sides are congruent? The answer is yes, right? We're talking about AC and DF. And our side condition is met. The two triangles, therefore, are congruent. ABC is congruent, triangle DEF. And the reason is the angle side congruence theorem. So give you a chance to finish writing this stuff down, and we'll go on to some more examples. Okay, so each diagram shows two triangles and two congruent angles and sides. Identify one additional pair of corresponding angles or sides such that if the pair were congruent, the two triangles could be proved congruent by angle side. So, okay, what do we got here? We've got an angle and an angle, so we got one angle. And now we have another angle and another angle, so we have another angle. Well, what's missing here? We need a side. Which side? Well, this would be the included side. So this is the side, if it's included, that doesn't work. Right, I can't use the included side. So I would need to know that either if the triangles are congruent by the angle side theorem, then either AB, which is the non-included side, is congruent to DE, or BC would be congruent to EF. One of these two things needs to be true in order for these two triangles to be congruent. by the angle side theorem. So let's try this other example. So we've got an angle, right? Got an angle. Condition 1. And I've got this side, right? This side and that side. So we've got a side, but we need them to be non-included. So to be non-included, that would rule out angle B, and that would rule out angle F. So that leaves only two possible choices, or I should say maybe even just one possible choice. In order for these two triangles to be congruent, right, if the triangles are congruent by the angle side theorem, then we would need to know that angle A is congruent to angle E. That's what we need to know. So I hope that example makes some sense. Now let's get to the my HRW exercises.